Okay, first we think about it like, okay, like what we have done in previous session. Okay. So we started first with the big data fundamentals, right? Now people like now you guys are understood, right? What is big data? Why we are going to use big data? What are the different V's are there? Types of data, right? Structured, semi-structured, unstructured data. And what is Hadoop, right? Why Hadoop came in picture, right? Because for the large data analytics, the Hadoop came into the picture, okay? And what are the characteristics of the Hadoop, right? Right, you see that flexibility is there, like economic, right? Hadoop is open source, right? So a lot of features are there in Hadoop, okay? So Hadoop is not only one single component. Hadoop is like computation plus storage. Okay. So computation part is called the MapReduce. Okay. Nowadays, people are not using MapReduce, but we need to understand the fundamentals of MapReduce, how MapReduce works. Okay. And the second is the storage. So storage is not outdated. Some people are saying Hadoop is gone, Hadoop is gone. See, Hadoop is based on the the block size, right? That is a very large block size, and that can process the data very large amount. So whatever Hadoop file system is there, that is still there. If you see any particular cloud, any cloud, you just tell me, right? AWS, Azure, GCP, every cloud is providing the Hadoop Spark framework. Okay. So Hadoop Spark framework for the data analytics is not gone, but they have given their own service. They have given, like EMR is in AWS. They have given their own service to use Hadoop on their platform, right? And you don't need to worry about how to install and everything, right? You just select the application, what application you want to keep it in your cluster, like you want to keep it Hive, you want to keep it Scoop, you want to keep it HBase, Spark, okay, and HDFS. So HDFS will come automatically with the Hadoop. So everything will come by these selecting the application on their cloud service. Okay. If we talk about Azure is having HD Insight. Okay. So HD Insight is there. In GCP, there is a data prop. So we are not going away from the Hadoop. Okay. MapReduce is, we can say, okay, we are not using MapReduce, a completely Java-based framework. Okay. And MapReduce is not being used, but still Hadoop is there. Okay. And if we learn, right, basic in our local Ubuntu, right, like Hadoop, this component, right? So same thing we will learn over there. The only difference is in the cloud is how these applications, these component in the Hadoop ecosystem will be installed, okay, within this service. Okay. So that part is an additional thing, and that you will learn when you are going to the cloud. But if you are learning first basic fundamentals of these services, right? What is Hive? What is a component of Hive? What is Scoop? What are the component in Scoop? How we do Scoop import? What is the HBase? HBase is the NoSQL database. How many component of the HBase? HBase master is there, HBase region server is there, HBase commands are there. So still HBase is used, right? I'm also using in my project HBase. HBase is a NoSQL database of the part of the Hadoop ecosystem component. Okay. And Spark, we well known, right? Because Spark is still being used, and many people are using Spark because Spark is the backbone, right, in the data engineering. Okay. So we have started first fundamentals things. Okay, big data, right? What is the concepts of the big data? What is a Hadoop? Okay, and the next thing we did, that is more important thing, is the Hadoop commands. So I showed last time when we did SDFS, DFS, or Hadoop FS. Okay, so you can see list of commands. Okay, so I will show you again, like those are the around 30-40 commands are there, and those 40 commands you need to understand. These are the Linux commands only, but we are using the prefix is a Hadoop. Hadoop FS is a prefix. Okay, and how we use those Linux commands in the like Hadoop file system, how we can use it. Okay, so that we seen in the last time. Okay, and you have to practice those commands. Some admin command also there, but those are very few commands because generally the developers are not using those admin command. But I told last time, like safe mode is there, like status command is there. One command is some more command balancer, some commands are there, but mostly we are not going to use those commands. Okay. And next thing is Hadoop file system, right? SDFS architecture we see, right? So what is our SDFS architecture? There are the two core component of SDFS, like SDFS architecture, like name node and data node, and secondary name node, data node, and secondary name node. So name node, data node, we understood, right? What is a name node? What is a data node? What is a secondary node? What are the function of these? Okay, how the Hadoop architecture works. And there is a read anatomy and write anatomy, right? How we can read and write the data in Hadoop file system, right? We generally know the commands are there, right? We know for reading and writing data, we have put command and get command we use. But actually how those command internally works, so that is read anatomy for SDFS, and write anatomy. So here is the client is sending the request to the name node, and name node is delegating the request to the basically it is allocating the data node to read the data, and that particular file you are going to read and what are the blocks are distributed on the data nodes, it will be read by the client directly. Okay, so once name node will assign the IPs, right? Because data is distributed on the different data nodes, and who knows this information? Name node knows that information, and name node this information will provide to the client who is requesting to read the file. Then client will start reading the data. And there is the concept of high availability, right? So we know high availability thing is like there is a replication factor is there, like high availability or fault tolerance, we can say, right? If any one data node is down, how the other data node will provide the backup, right? Provide the same data which is client is reading. Okay. And high availability thing is there, so that comes in the read. Okay, so same thing, like if I say write anatomy is right when I'm going to write the data, in Hadoop file system, so how the data will be written. Okay, so these two, write anatomy for SDFS. So how to, so write part also, see high availability, scalability, these are the common features. Okay, because whenever either you are reading a data or you are scaling your your cluster, right? So these things will come in picture. Okay. Okay, so these are the common features. These are the features for the like maintaining the cluster, right? Scalability, maintainability, security. Okay, so in Hadoop file system, this is a normal file system, but it is on top of the our Linux file system or Ubuntu file system, Windows file system we can install. And on top of that, like we can read and write the data. We can do the analytics on top of the data on Hadoop file system. Okay. So next thing in Hadoop file system is like this is a how many ways you can interact with the Hadoop file system. How many ways to interact Hadoop file system, SDFS. Okay. So one way we see that is one way is through command line. Okay. Command line using Hadoop developer command. Hadoop developer command. Okay. So this is the first way to interact with the Hadoop file system, right? You can read, write, you can rename, you can remove file, you can copy file, anything you can do with the command line. Second way is, suppose if I ask you, right, you don't have access, direct access, you don't have Hadoop file system, okay? Or some automation things I want to do. Suppose I'm saying I have to create 100 directories. So how can you do the 100 directories creating? So there are the two ways you can do, programmatic way. One way is you can do through shell script, okay? Shell script, you will write a scripting, and whatever Hadoop command you are writing, right? For the single command you are writing Hadoop fs mkdir, okay? If this command you will iterate in the loop and you will be providing some suffix, right? For directory, right? Okay, suppose the first directory name is dir, and then I will plus I value, and this I value will iterate, from 1 to 100. Okay, so how many directories will be creating? It will be creating starting from the 1 to 100, right? dir1, dir2, like that. Okay, so that is a one way, like we can use a shell script. Because if I'm going to try to create the manual way, like through command line, like I will take 5, 6 minutes, 10 minutes, I will take it, right? Because it's not the right way, right? To do some automation things manual. Okay. So if you want to do this kind of automation things, so one is you can do shell scripting, and another way is SDFS has provided Java API. So SDFS Java API is a like programmatic way, like you can write a program, and that program is having the you will be connecting to the Hadoop file system and call some Java methods. Okay, and these Java API method, if I say the Java API method, there is a mkdir method, something method name is there in the Java. Okay, I'll show that. So that Java method will call internally the command. Okay, shell script command, and that will create a directory for you internally. So here we can see like if I want to write Java API, so in this case I have to create a Java project, I have to create a Java class, I have to write, and then I have to create a jar, and then I have to run a my class, right? I have to run. So Java minus jar, you can run class, or directly if you are running in your editor, you can write class and you can run main program, right? You can run the main program. Okay. So main program you can run. So this is little like lengthy way. Okay. If you do shell script, it's a very quick way because you can write a very small shell script and you can run your shell script and it will do the connection with the Hadoop file system and create a directory for you. Okay. And third way is that is more quick way, that is basically REST API way. So REST API, suppose you don't have access of your Hadoop file system. Okay, you cannot run the Hadoop developer command. Okay, and even like you are not going to use the programmatic way. So there is a REST API like curl command are there. So there is a REST API curl command, and these curl command you will be running in Unix, right? Unix, and you know, right? Whenever you want to call any REST command, you have a different methods are there, right? Get method is there, post method is there, put method is there. So for different command, different method is there. Suppose you want to read the list of directories and files from Hadoop file system. Okay, so you will use the get method. Suppose you want to create a file in Hadoop file system, create a file or directory. So which one method you will? Post method you will use. Okay, so something like you want to put method you can use when you are updating some file, like overriding the file. So you can use the put method. And delete means like you want to remove some file, then you can use delete. So these will be called internally, right? So basically you will be defining your REST command for these REST API method, get, post, pull, put, and delete. Okay, and this is a very quick way. Just you have to run one single line REST curl command and you will be able to see the result in your Hadoop file system. Okay, but this last one is specifically when you don't have access of your local Hadoop file system and you have some particular edge node or gateway node where your Hadoop file system is there. Okay, so you will be having a access of edge node, okay, gateway node or gateway node. Okay, and this gateway node, which is entry point, which is the entry point for your entire cluster. So your entire cluster is connected from this edge node. Okay, and this edge node or gateway node, you will run your curl command. Okay, REST curl command. Okay, so I have already talked about the first one, but second, third one I have to tell. Okay, REST curl command. Is it clear so far? So this is the so far we have to learn. These are the things we have to learn about the SDFS. Okay. Okay. Is it clear this one? Okay. Okay. So next is the MapReduce. So MapReduce. Hmm,
8 बजे
somebody is asking. Okay. Okay. So when we come to the MapReduce, okay, I already talked about like MapReduce. We will not be doing more practical because nowadays nobody is asking you to write a MapReduce Java code, because MapReduce we can write either in Python or Java. Okay, but Python one is not a distributed one, it's a single threaded. Okay, like you can just test MapReduce program in your local machine, right? You want to test the word count program, so you can test locally. Okay, but Java one is like you can create a jar of your MapReduce project and you can run a job in cluster. Okay, so that can be used as a distributed. Okay, so when we are going to use the MapReduce, right? So we need to understand what is the fundamental of MapReduce. Last time I explained like MapReduce architecture, right? MapReduce is a paradigm, right? It's a framework, right? And it's a multi distributed and parallel processing framework, okay? And it has the two function. One is a map and another one is a reduce function, okay? So first we need to understand what is map, what is reduce, okay? So map is basically splitting the data across the cluster and running your processing the data parallelly into all mapper machine, okay? And once your data process in all the mapper function will execute it, then your data will be shuffled. The next phase is comes that is provided by the Hadoop, that is a shuffle and sort. So if you see here, shuffle and sort. So actually map and reduce our function. We write the code for that, but shuffle and sort is provided by the Hadoop framework. Okay. So shuffle and sort, we don't need to write any code. And in between a map and reduce, this shuffle and sort comes in picture. So first we are splitting the data across the machines so that our parallel job, the tasks are distributed and parallelly running. Okay. And once the map is completed, the shuffle and sort will bringing together the same key at one place. Why we are bringing together at same place? Because I have to do aggregation. And before doing aggregation, if suppose hello is word is at 10 mapper machine, different 10 machines. So I have to bring at the one place. Okay. So that I can aggregate hello comma 1 plus 1 plus 1, 10. Okay. So like that way, like shuffle and sort will do first shuffling and then sorting. Sorting will arranging the keys in a sorting order. Okay, so that is the Hadoop is doing. Okay, Hadoop SDFS framework Hadoop is doing, MapReduce is doing. And once shuffle and sort is done, then what is the reduce phase? Reduce is just doing the sum of the values of that particular key. So suppose here high is 1 and 1, so 2 will become. R is 1 and 1, so it will become 2. So final result will be your all words will be having the count, the final count. Okay. And this word count will be written into the output file. So here we are giving an input as a text file, which is having a text of line of data. Like this is example, like hello.txt, which has 2 lines of text. Hello, hi, how are you? Hello, hi, how are you? So I should get the result. Every word is two times. Okay. So this is just example, right? The file could be very, very large. It could be a GBs, TBs, whatever size of the file it can process, because Hadoop file system is like basically for the large amount of data. Okay. But the condition is your data should be on the Hadoop file system. Then only MapReduce will work. The one limitation with the Hadoop ecosystem component is they are tightly coupled with the SDFS. If your data is not in SDFS, they cannot process the data. They cannot do the analytics on the data. So if I talk about the Scoop, HBase, Flume, everything need Hadoop file system. Okay. So if your Hadoop is not installed, so Hadoop means we are talking about here SDFS and MapReduce. So when your Hadoop is installed, then only you can install other component. Okay. So the first prerequisite for the other Hadoop ecosystem component is Hadoop is installed first. Okay. So which will come by default, SDFS and MapReduce. And then you can go next component, Hive, Scoop, HBase, that you can do randomly. Okay. So first thing is if Hadoop is not installed, SDFS MapReduce is not installed, you cannot do anything. Okay. So that is the mandatory thing. So that is the reason Hadoop ecosystem component has the tight coupling with the SDFS. But Spark is not like that. Spark is completely flexible, right? If your data is in local, so there you can use the standalone mode. If your data is in Hadoop, you will be using the Yarn cluster. So Hadoop Spark has the backbone component is cluster manager, and this cluster manager is the 3 types. One is a Yarn, standalone, and even the one more is a Kubernetes also there, standalone, and one more is this Mesos. Mesos is some other distributed application purpose we use, and one more is that Kubernetes. So this Kubernetes come for the containers. Okay, so this cluster manager is especially for the if you are going to use your Spark in the Kubernetes, okay, in the container environment, then you can use this Kubernetes as a cluster manager. So this cluster manager will decide, right, where you are processing your Spark job. If you are processing your Spark job in a local, right, without Hadoop file system, you will use standalone cluster manager. So this kind of setting you will do when you are doing the Spark submit, when you are submitting your job, there you will be deciding minus master, like local client, and there is a one property also, deployment mode. Okay, so deployment mode is a client mode, cluster mode. So that way you will be configuring your cluster manager. Okay, so now we are talking about here like how we are processing the data in the MapReduce. So this part is everyone understood, right? How map works, how shuffle and sort, and how reduce is giving the output. I will show you the code, how this code runs, that I will show you, because sometimes if nobody is asking you to write code, but someone can ask you what is map, what is reduce, what is the code snippet of MapReduce. So just two lines of code. If you cannot write code, but at least you can explain the code. So that is enough for someone to understand you are like now you understand the basics fundamental of MapReduce. Because MapReduce is not only used in the big data, MapReduce concept is used in the MongoDB also. There is a MapReduce framework is there, like for aggregation of the data. So MapReduce framework is a common approach, right? An approach for the splitting data and processing data and aggregating data. So this is like approach is how the distributed multi-processing framework can work. Okay. So it's a different thing. Like MapReduce is using Java code. It's a 200 lines of code in Java, because Java is everybody knows, like anything you are writing in Java means you are writing not a small code. Okay, because please. Oh, yes. Okay, so what I'm saying is like Java is always lengthy code, right? But sometimes we have to write some specific libraries we want to use. Then we go for Java. Definitely we go for Java because Java has rich set of library. But now the same thing is provided by Python. Now everything is done in Python, and Python is a scripting language, and it is very small code you can write, right? What code you write in Java 10 like 100 lines, here in Python you can write in 10 12 lines code. Okay, so that matters, right? How so, but end result is coming same. Okay, but here MapReduce is nowadays not being used because it's taking up productivity more, right? Like people are productivity is less because people are writing more lines of code. Okay, right? Okay, so this part is clear, everyone. So there are the three classes are there: driver class, mapper class, and reducer class. So driver class is the starting class from your MapReduce program start, and it's a main function. It has the main function, and there is we are configuring our mapper class and reducer class properties. Okay, so let me show you all the this driver class and mapper class code. Okay, so I have configured my IntelliJ IDEA, and this one I'm running in my Ubuntu. Okay, in my Ubuntu in my Windows. Okay, so how I configure it, I'll show you. So simply I have downloaded my IntelliJ. I downloaded my IntelliJ and community edition, and I kept it in my software folder. In the software already I installed Hadoop and Hive over there. So there is a Hadoop home. If we go my user softwares, so here the IntelliJ IDEA. So you need to download it, extract it, and there is a bin folder, and you have to run idea.sh. So if you see in my command line, so I have run here. This is I'm running here idea.sh. So when you are running idea.sh like this in the bin folder, you will see one IntelliJ editor will open. Okay, and this IntelliJ editor is using my workspace in my Ubuntu. Okay, and here suppose if I want to open a project, this is my MapReduce projects is there, like different code, right? MapReduce word count program is there, partitioner program is there. So these are the programs. I will explain those one. Okay. So here, if you see my workspace, so it will be showing my Hadoop file system, right? This you can see. So first of all, I copied this MapReduce WC project in idea project. Anywhere you can keep it. Okay. And then you have to open this project in the IntelliJ. So you can open in IntelliJ. So you will see the project will come like this. And it's a Java project. And many people know how to create a Java project. I can show from the scratch also. So it's very easy. Like you can go to new and you can create a Java project. Okay. Project. And you have to use the Maven, right? Because Maven is a build tool. Okay, we are aware of that. Maven is a compiler and build tool, and we can create a jar, right? So we are using a Java, right? Already I talked about, right? MapReduce, we are using Java. So we can give the project name. Okay, so I'm giving MapReduce WC1, any name you can give. And here you select Maven, right? Maven is a build tool. I'm selecting it here. And now here is a one more thing you will see here, the Maven dependencies, right? This group ID and artifact ID. So by default, it's taking this. Okay, some package is taking. Okay, I can change that package. Okay, so if I want to keep it my own package, okay, com.test. Okay, and artifact ID is your project name. Okay, so whatever your project name will be there, right? This project, the same is taking as a artifact. Okay. So once you defining this and you are choosing this is a Maven project, so your pom.xml will come. Okay, and that pom.xml has only unit test case dependency. Okay, so other dependency you will add manually, and it will ask you here whether you want to open in the same window or you want to open in a new window. If you keep it in new window, you can compare, right? Like, okay, one other window, you have one project, and other window, you have other project. Okay, but you make it this window means it will overwrite. Okay, so I'm opening in the other window. Okay, so if you see the basic structure of the MapReduce is created. Okay, so if you know, right, here is the one Java project is created. Okay, and Java project one main dot, if you see this hello world class is created for you. Okay, so if you want to run and test this project, just run this main class. So you will see the hello is printing. Okay, so first of all, we have to create a project. So I just showed, right, how to create project, because we need a Java in Hive UDF also, because when we are creating a Hive UDF user defined function, that time we need a Java project. Okay, and when we are using HBase also, HBase we can create a Java project to connect HBase. So I told, right, like whenever I need some automation things, I want to write some code in Java and I want to connect my Hadoop file system ecosystem component, I can connect. Okay, so that part I will do through Java, right? If I want to go through programmatic. Okay, so here this is just a one class is there. Now what I need first, right? Because I need a first to add my Maven dependency. If you see here, okay, here the unit test case is not added, the dependency. So I have to add dependency management. Okay, so dependencies are there, and within a dependencies, I will add one dependency. Okay, let's see how many dependencies are there in this one. So I'm using only one dependency. This unit test case one is generally by default it comes. Okay, if it is not coming, it is not a problem. But if you are using any test cases like unit test cases like you are using, for that you need this dependency. Without that, you cannot run JUnit test cases, right? This is a developer level test cases. And generally, when you are writing a code in PySpark or anywhere, PySpark has a different framework. That name is the PyTest. So there is a different framework in the Mockito is there in the Java, right? And JUnit is there in the Java, right? So different frameworks are there for unit testing. Okay, so we have to copy this dependency. So this dependency is needed for the Hadoop. Okay, so I will be copying this. Okay, so inside the dependency is coming, and I will reload this because the jar is already there, because I have already like run my MapReduce project, right? So jar is already there. But if you are doing first time, in that case, it will be okay. So here So in that case, right, if I reload project, Maven, reload project. Okay, when I do reload project, it will download the dependency if you are doing first time. Okay, so the dependencies come into M2 folder, right? There is a one M2 folder will be there in hidden folder, and their repository folder, and there your this all dependency jar will be downloaded. Okay, now next thing is, once this dependency is there, you will not get any compilation error when you are writing a code, source code, when you are writing a source code. So when you are writing a source code, you will not get the error. Okay, so there are total 3 files are there. Let's see. So one is driver class. I talked about this is my driver class, and this driver class is nothing but my main class. Okay, the main class which is having the main function. So your execution, it's a starting of the execution point. Okay, where from your the code will start. Okay, and the driver class, we are creating a job instance. Okay, so there is the APIs are there. These are import statement. You can see all the Hadoop Java API. This is a Java API in Hadoop. Okay, and this is a creating a job object, and you are setting which mapper class you want to use. So when you go to word count mapper, this word count mapper is a separate class, and even this all three, driver, mapper, and reducer, you can create in a same class. Okay, you know the concept of like one public class can have like you can have a multiple inner classes are there. Okay, so either way you can do, that is fine, because if you keep it separate, it will be easy to understand and you can easily do the change, right? Because you know mapper class, you have to do change. You will go to this mapper class and you can do the change in the mapper class. Okay, here is lot of extra code is there that is not needed. Only just this map function code is needed, and this is the 3 lines of code. This 3 lines of code, even I can say this 3 lines of code is enough to understand what map function is doing. So what map function is doing, I told like map is basically splitting the data and distributing into the number of mapper machines and doing the word count. Doing the each word is a 1 count it's giving. Okay, so that is map is doing. So that is a map. So map is first is splitting the data. You can see it is splitting the data. So splitting there is a being done by space character. You know, right? Every word is separated by the space. If you see here, one space is there, one space is here, one space is here. So wherever the space is there in the file, it will detect that space and do the split. And when you apply the split function, whether you are using Python, Java, or any programming language, you will convert a string to array. Okay, so here the syntax is string array. Okay, and it's a purely Java syntax. If you are writing a Python, so Python, you don't define any data type. You directly write ARR equal to data.split. You can write like that. Okay, so you will be getting an array, and array, you are iterating the array by loop. Okay, so in the Python, you have for I in the list, right? Like this you write. But in Java, you are writing in the this way, like it's an enhanced for loop. So here you are taking a list of values in the array, and each string value you are giving 1 count. So how is difficult? So here the main understanding point is in the map function is you are splitting the line of text and converting into array and iterating the array and get and the giving each word is a 1 count. So what you have done in this map function, this part you done. Each word you are giving 1 count, because every word is a 1 only, right? So every word is 1. Even the hello is coming here one more time. So this hello is again separate one. Okay, so every word is a 1 count. Okay, if suppose if hello is coming one more time here. Okay, so you are doing hello comma 1, hi comma 1, again hello comma 1. Okay, so here is our goal is to give every word is 1 count. Our map function done. Okay, nothing else we can, no need of writing and anything else, because this map function, this line of code is enough. Okay, and if I go to the reducer class, so I told after the shuffling and sorting, my words will be coming as a list of values. Okay, so if I look at here, my reduce function is taking input parameter is a key and value is a list of values, right? So if 1 like 3 times the same key is there, so how many times 1 3 times 1 will be there. Okay, now what reduce function has to do, first of all, and one more thing is here, you are able to see here the data type is int writable is there. Okay. And in the map function also, you see whenever I'm writing the data to the context, it is making it int writable. The thing is, the Hadoop is completely distributed framework, right? Your data is transferred over the network. So can you think of like if primitive data, like simple int data, right? I've talked about this int data, this int. So can you transfer this int data over the network? No, right? Because primitive data cannot transfer, right? So data is serialized. Data is transferred over the network using the byte string. You know, right? Data travels in the packets, right? 0101 binaries, digits, right? So every data, right? Whatever you are transferring over the network, you make it a serializable type, and Hadoop has provided one every data type has one serializable type. If I say int is a primitive type, the corresponding serializable type is int writable. For string, they have given the serializable type is a text type. Okay, so your data travel over the network and on the other machine, and context is a common variable which is sharing the data across the cluster. Okay, so how map will know to write the data, where to write data or reduce? So one context variable is there. So here is the context, which is writing the data. Okay, here is the context, reading the data from the context, again writing to the context. Okay, so finally the data is finally written context means the output file. Okay, here in the reducer, again they are writing into the context, and this context final is writing the data to the output file. So what is the logic here? The very simple 3 lines of logic again. What is the logic? I'm creating a one sum value, right? Like final output value. So I just defined what is my total count value. I assume it's a 0 because anything I start from the 0, right? Then I will add 1 plus 1 plus 1, right? And I have iterated the list of values. And here one more thing you will see, values dot get is there because this get value has type is int writable. You cannot read directly. You cannot do process directly. So you have to change into primitive type. Then you will add into your original value. And this thing assignment operator, you understand, like plus equal, like every time you are adding up the values and finally you are getting the sum, and that sum you are writing as in your context for that particular key, right? So if I say hello is coming 1 comma 1 comma 1 3 times, so my final output will be written in the context hello comma 3. Okay, so that will be my final output. So this is just I explained it. What are the 3 classes needed? Like driver, mapper, and reducer. Now I have written this code, but I want to execute this code, right? How to test this code? Okay, so if I say I want to test this code, I can test in this editor itself. Okay, or if I want to test this code in the cluster, then I should have my data on the cluster, right? Whatever input file I want to give, I can give in my cluster and I can run. So let's see first how to run locally in this editor. Okay, because if you are able to test your logic, then only you will test your code in the cluster, because logic is important. Because if logic is not correct, there is no point to test on the cluster, right? Because cluster is used for large amount of data testing, and if you are creating a jar here and moving the jar on the cluster, that is not like easy part, right? Because you have to do a lot of process. Okay, so that is the reason for the small data we will test our logic in locally, and once we verified our like testing, right, our logic is working fine for the small data, just for a simple like just 2 lines of text file. So I can say, okay, my code logic is working fine, then I can apply this logic for the huge amount of data. Okay, so that's a process basically. So that is the reason this MapReduce code we are writing, same like Spark code also we can do. We can test the code in the our local, right, in the editor like PyCharm editor, or if the Spark Scala code we can write in the IntelliJ and we can test, and then we can create a jar and then we can move the jar into the cluster. If it is a PySpark code, we need a py file, that is the main program file. Okay, so that we move to the cluster. Okay, so first of all, whenever I'm going to configure, like there is an edit configuration is there in the in the IntelliJ. So there, so if you want to test any application, because we are providing the input parameter to my MapReduce program. If you see in the driver program, we are giving two input parameter. So one input parameter is the input path and one is the output path. So input path is nothing but your directory where your input file is there. And this is the output path, right? Which you are giving us some new directory where you want to generate output file. Okay. So output file, you don't have control to keep a name. Okay. The name will be taken is a part -r-0000. Okay. So that name you cannot have a control. You cannot do. You can later change it. Once your file comes in your Hadoop file system, you can rename the file. You know the command. Okay. Or programmatically you can do later by using the shell script. Okay. So if I want to test the application, so this is the partitioner I'm using. So I'm disabling it. So just I'm commenting this line, my partitioner will not work. If I'm commenting this combiner, because these are the additional utilities, okay, I'm commenting it now. So just in the job, whatever you want to use, just configure that. And whatever you don't want to use, you can just uncomment it, just comment it, then it will not be used in your application. You know how to comment the lines, okay? So once you comment the line, it will not be used, okay? So now we are using a mapper class and reducer class. And what is my output key class? So whatever output you are getting in the reducer, this is a text type. My output is a text is a key, and the int writable is the, you can see here, this is a text is a key and int writable is a value type. Okay. So this is my return type, my final output type. So that I'm defining here output key and output value. Okay. And two other parameter is input and output path that I'm going to give. And this particular line is basically I'm going to do for, suppose my directory is already created and you are running your program. So your program will fail. You know, in Hadoop, anytime you are creating, you are running your program second time, it will be giving you the problem, right? The directory already exists, right? Output directory. So in that case, either you use this way, it will delete itself in the program, or you manually delete the directory on your Hadoop file system, then it will work. Okay. If you are not using this particular lines of code. Okay. And the last line is actually this driver is starting point, and it will go to the control to the mapper and go to the control to the reducer. And finally, you will return back to the driver. Okay. So here is this condition is there, job wait for completion. So if you are getting success, right, like this condition is giving a 0 value, means everything is coming on the control back to the driver, then you are returning 0, and that means you are successful. Okay. If suppose something happened in the mapper class or reducer class, some error comes, so you will get the return code is 1. This return code 1 means your job got failed. That's an indication. Okay. So 0 means success and 1 for the failure. Okay. So anyone has any question, doubt? Okay. So when I'm configuring my application, so I'm setting it here. What is my driver class name, my main class? So this is the main class name. So what count job is my main class, and what are the two parameters for my job? So here is my test1 directory has one input file, and test1 has output directory. So let's verify. I can create any file. Okay. So if I go to my home directory, test1. So this one has one input file and output directory already there. Okay. So in this input file, let's see. It should open in the Linux only. Okay. So this is the line. Okay. This is a text of line is there. Hello. I make it hello. Okay. So I save it. Okay. So this is the line of text is there. Okay. These are the two lines. Okay. Now, and this is my output directory. I'm not deleting output directory because my program is handling that. Okay. And now I'm going to run this code. So what code you written? Exit code is 0, right? There is no error, okay? Now I will be going to check my output. So output directory, and here is file. Can you see the time? 10:57. The output is created at the 10:57. That is the latest just now. Okay, you can see the date also. So what file is created? Part-r 0000 file is created. Okay, let's see through command line because it's taking. Okay, so we can check cd test1. Okay, so I go to output folder. Okay, cat. I'm showing you the file here. Can you see R is one time, hello is three time, aho is the one time, U is the one time, right? Now I just add one more word here. Just we are doing the retesting, right? Whether it's working fine or not. Okay. How many times hello is there now? How many times hello is there?
4,
4 times?
5.
5 times. Okay. So now I will be executing the same program. I don't need to do anything. Just click on this. It is executing the same program. Okay. Okay, this is done now. Now I'm just doing again this cat command I'm doing. Actually, I have to go back and then come. The file is updated 10:58. Okay, let's see cat part R. How many times hello is coming now and how many times hello is there? 3 times and 5 times, right? So it means our word count is working fine, right? As per the logic, right? So my logic is working fine. I have checked it, right? I run the program locally in my IntelliJ and it's working fine. Now I want to move this to my Hadoop cluster. I have already Hadoop is there, okay? So suppose I want to check JPS command. First of all, my SDFS, my Hadoop is running or not. If you see here is no Hadoop, but then how this program run? That's the question, right? Because I'm not running on the cluster. I'm not running on the cluster. This program just I run in editor and this program is run through the jars. Okay. It is not using any Hadoop component of the cluster. Okay. So that is the reason without I have not started even the Hadoop, my program is able to run in my IntelliJ. It is just because of the jar, right? It's just because of the jar and it is just for testing. It is not a cluster kind of configuration it's using. It just using just a jar and then it is just testing purpose. It's giving a result. Okay. Now I want to start on the Hadoop file system. So first I have to start the Hadoop services. So I'm starting my Hadoop services. So IntelliJ we are using as a testing mode, right? We are development plus testing. But when you are running on the cluster, that is like deployment mode, right? You are using like prod, UAT, QA environment where you are testing in the cluster. Okay. Now I check my JPS. Okay. So all 5 services are coming. If I want to check my Hadoop file system, Hadoop fs minus ls /. So I can see my Hadoop file system root directory. Okay. So Hadoop file system, these are my directories. Okay. So I just create a one directory for my this testing mkdir. I just give the name MapRed. Okay. And my input file, where it is my input file. So I will copy, I will create one more directory in Hadoop file system input so that I can keep it separate for my output. So MapRed /input. Okay. So I'm just keeping my input file inside this. input directory. Okay, so I need to copy, right? So I have to go one folder back, and here is my file. What is my file? Test.txt. So can anyone tell what command I will use to copy this file to Hadoop file system in input directory?
Hadoop CP
Put
command.
command.
CP command. Okay. Anyone else?
Put command.
What is full command, right? Just put is a word, right? I'm asking command, complete command I'm asking.
Hadoop HDFS. Sorry, DFFS
Uh,
-put
hmm,
and test TST
hmm.
and home directory June 1st.
No, I have created separately now the directory. You tell that directory, right? I created. Hmm.
Okay.
You are able to see directory, right? Yeah. Hmm.
MapReduce, I mean map and read
Hmm.
and input
Hmm.
and
Anything else?
test TST.
No need to give. See, if you
Yeah, sure.
okay, if you are having already some file, then you can change the name. Okay, it will go as a same file. Okay. If file is already there, suppose if I run this second command and it will give me the error, right? So what I should do if I want to overwrite the file with the new content? So what should I do? It is giving error, right? Now what should I do? Now what should I do in this command? My command should not give the error.
We need to add f in front of the dash minus f. Forceful.
Forceful, right? Okay.
Yeah.
Minus put minus f. Okay. And if will come after put, because put is a main option, right? And then sub options will come after the main option, and after the main option, and with hyphen keyword will come hyphen. Okay. So this is like we can say what we call it, right? What we call it, like this kind of things we call it. Okay.
Argument.
Argument is not argument, like it's called something, attribute something. Okay. So
In
now the file is written. Now I have to, my input file is there. My jar, where is my jar? Okay. So I need a jar because this complete code, I have to create a jar. Okay. So how to create a jar? So there is a Maven I have to bring in picture. Okay. So now, so far I done the application type, that application for running locally, right? In my IntelliJ. Okay. For any kind of application means like you are running in locally in your IntelliJ. But when you want to create a jar, you have to use Maven and you have to create a new configuration, right? I'm showing you the new one, how to create. So just you create a new one, some name you give, suppose you say build. Okay. And you have to give the run command. Maven has the different commands are there. So we will use clean install command. So clean is a one command and install is a one command. Clean for the whatever your previous dependencies are there, it will clean and then it will recompile. Okay. And install is basically creating your jar, because this entire code classes you need, right? When the any code, Java, Python is converted into the byte code, like classes, right? So those classes will be created by this install. Okay. So you can read about Maven, right? Like I will share the tutorial, right? So this is a life cycle method of the Maven. Okay. And what is my working directory? My entire directory I'm giving MapReduce. Okay. So I'm saying the complete app, this project jar you create. So definitely there may be a multiple main class can be there, right? Because there are multiple main class can be there. But when I write my command, Hadoop jar command, when I'm running a job, I will specify my main class so that I will run, because jar has multiple main class. So which main class you want to run, that we will specify in the our job. So here just we want to run this build, this Maven build, and it will create a jar. And where it will create a jar? In the target folder. Okay, so target folder, you already see here the jar. This is an old one. And whenever your code changes happen, and this jar will be refreshed. Okay. So this jar, either you go to this target folder or copy this jar in the some folder. Okay, like this jar is created. Now this jar I will copy. Okay, and I can place this jar Right now, I'm in which directory, I can keep it there. Okay, I'm in the test1 directory. So I keep it jar here. Because everything, this is through WSL I'm doing. So it is easy to copy paste. Okay, where is the paste icon? Why the paste is not coming? So copy. Otherwise, we have to do Linux command way to paste. Okay, this way it is not doing. So, okay, we do the Linux command. So we are in this directory, right? This directory is in the idea project, MapReduce WC. Okay, so idea project. PP. So idea project. Okay, and then MapReduce WC, and there is a target, and there is a jar name is word count. W capital. What is the MapReduce? Starting is a MapReduce. Okay, so this jar I want to copy to my current directory. I will do dot. Everybody knows this Linux thing. Okay, so now I will see ls. My jar is here. Okay, now I will run Hadoop jar command to run on the cluster. Okay, so jar is no need to copy in the Hadoop files. Only data is mandatory. The whatever your input data is mandatory on the Hadoop file system to process. Okay, and output data also will be created in the Hadoop file system. Okay, so Hadoop jar is a command. So if you just press Hadoop jar, so it is giving you the input parameter list, because I have not given the complete list of parameter. Okay, so Hadoop jar and jar name. What is my jar name? MapReduce jar. Then is asking me to main class. So I told you there may be many different jars, main class are there. So I'm going to take it my jar. This is my package name and this is my class name. Word count job. Okay. So org dot the fully qualified map, the package name you have to give, and the class name. Okay, this is my class. Okay, after that I will be giving argument. Argument is like I have to provide input and output. So first is input, means complete path you have to give every time, right? In the Hadoop you are giving. Okay, slash input slash what is my input file name is test.txt. So this is my input file name. This is my input directory. And second parameter is, you remember, right? I gave in locally in IntelliJ 2 parameters, same parameter, but this time the path will be Hadoop path. Okay. Now I'm saying MapRed slash output. This output I'm creating a new directory. Okay. Because MapRed directory already there, but output directory I'm going to give a new directory where I want my result. Okay. That's it. Now I'm going to start my job. So now you will see the log. Last time you seen in the IntelliJ, you didn't see any log, right? But here in the Hadoop cluster you are running. This time is the job is running on the, even though it is a single node machine, right? But it is a cluster. It is, you can say, if your 10 node cluster, 20 node cluster in the office, right? You can see the data is processed in the cluster. Okay. But here is the one single machine. So you will not see that much improvement of the performance, but the cluster is large, then the improvement performance will be large. So if you see map 0 initially, reduce 0, then map will become process first. Once map is completed 100%, then reduce will start. So map 0, reduce 0, map 100, still reduces 0. Because why you can't start the reduce? Once map is not completed 100%, how can you start the reduce? So if I'm saying I'm doing a word count, and I'm saying if I have not completed this 111 count and I started reduce, so conflict will come or not? Conflict will come, right? Because that's the reason that reduce will wait for entire map should be completed. Okay, and then map, after that shuffle and sort. Okay, so there is a contract between the map and reduce. The map will complete first, the whole map, then only reduce will start. Otherwise you will not get the right result. Okay, so now you see here, this is the output of the map reduce is coming. So here you can see this is internally MapReduce is using, right? How many tasks, how much data it has read, how much data it has written. So these kind of things. So map input record is 2. So it found a input file 2 record means 2 lines, and it generated output record means 8 lines. Okay. Now let's see our output. Okay. Hadoop fs minus cat. Okay. First we see what file name is created. MapRed / output is my directory. Okay. Let's see what is a directory in Hadoop file system. What is a file is created. So I already talked about, right? Basically, whenever you are doing the job, it will create its own name. And there is a one more file is created success. This success is a 0-byte file. Is there anything in this file? Nothing. It's just for indication, like your MapReduce job is done successfully. You will see even the Spark also. The Spark, right, when it is completed, the Spark job, it will be creating a one success file. So this is a practice, right? Like, okay, whenever the job is completed successfully, then it will create a one empty size file, 0 size file. There is nothing there, just indication, because you can see here the 0 is there, right? So how can you get the data? Now, if I check part R1, okay, so part -R -5 zeros. Suppose if it is creating 2 files, the next file name will come 00001. Can you see the same result? It's the same result. I'm just showing you how we are running the job in local in our IntelliJ, or how we are running a job in the cluster. Okay. So we should know both the ways, because the local editor is like just for testing. But if you are using the IntelliJ, you are using a cluster, that is your real-time cluster where you are submitting job and monitoring your job. Okay. And one more thing is this job, right? Suppose you want to see in the resource manager, right? Resource manager is a user interface where you can check the logs also. Same log, this same log you can check. And there you can see what is the allocation of your your processor, CPU, memory, right? Everything is detailed is there. Okay. So there is a IP. Directly it will start or not. Localhost 8088. So 9870, everybody know this is the Hadoop name node, right? This is whatever your Hadoop file system, you can see the view mode. So go, you can see whatever directory. Yeah, so you can see this is the MapRed directory which we created. This is output directory we got, and this is a part R file. And default block size is allocated 128 MB. Even the output size is a 26 byte, not even KB. Okay, it's just 26 byte, and it is taking this much size. So this is a Hadoop responsibility, how it will manage the storage, right? Because this particular 128, which is allocated to this particular size of the data, it will manage the other blocks, right? Other data in the same block. Okay. So that will be, but the block size is 128 MB. That is a default block size of the Hadoop. Okay. In the 2.x and 3.x. So that is the reason it is taking this particular size of the data in one block. Okay. And another one is localhost 8088. If it is not start like this, okay, so there is another one command is there. XTG. There is a XTG command. Actually, this is for WSL is the problem. So WSL, we use the XTG. So this XTG you use, this command will open your browser. Any browser you want to open through in WSL, you can use XTG. So I'm opening, I'm just my Hadoop file system. Okay, so I just paste this command. So it has opened a Chrome for me. And now you can see this is a cluster. You can see this is a job I just completed. Can you see the finish succeeded? Okay, and when I go to in this job, you can see. So whenever you are working in the real cluster, right, you will see this kind of Spark job, Hadoop job. What type of job it is, you will see. So it is a MapReduce type job. If your job type is a Spark, it will come Spark. If it is a Scoop, Scoop. It is a HBase, Hive, whatever job is there, it will come type. And here is a log. You click on that, and you can see here full log. And one more log. Actually, multiple logs are there. Syslog and console log. Okay, I think this log you can see. So this is the way like how to check on the cluster, and this is the application ID. And this application ID, there is a one application ID to allocate. This is application ID. So this application ID, so even you can have a yarn command to check all the list of application ID. You can kill the job. Somebody ask you how to check the log using the command. So yarn log command is there. Okay, so yarn log command is there. So yarn list or yarn. List. What is the parameter? List is not a command. Yarn. Okay, first of all, yarn you type an app. Yarn app. So yarn app minus app ID or list you want to do. So these are the all parameter list. Yarn app minus skill is there. Yarn app minus list is there. Yarn app. So yarn app minus list. Can you see? One total number of job 0. Okay, job is completed. Now it will not show. Okay, so yarn app. So suppose you want to kill the job. So yarn app minus kill, and then you give the application ID that I told you. So if you try to kill that application ID now, because the job is already completed. Okay, so what is saying it? What is saying has already finished, right? So if your running job is taking a long time, so you can use this command line way. Okay, so this is very useful, like whenever you are running a Spark job or anything, because this yarn command is a common command. Even you are using Spark or Hadoop or any job, okay, in the cluster, right? So you have to use this yarn app minus kill or yarn app minus list or yarn app minus log. So yarn app minus log, you can give your application ID, then you can see the logs in the command line mode. And you can take this log into some file. Suppose you say, I want to redirect log in some test.log. You want to transfer the log to someone. Okay. So it is unrecognized option minus log. Yarn app. Somewhere was there log, right? Insert fill list. I think not app. Yarn log will be there. So yarn log. Log. Okay, Abhi, right now that ID is not exist. Now it is gone. But if you are job is running, you can see. Okay. So yarn logs also you can see other parameter, right? Yarn logs. So yarn app and yarn logs both has a different parameter list, right? So yarn logs is related to log related, all this parameter list. This is a huge list. So you can see cluster ID, yarn logs, container ID. So cluster ID you can give, container ID you can give, log files you can give the log file. So there are multiple parameters are there. Okay, so this is clear, everyone. How to run the MapReduce job. So this is a one program we did. just simple word count program. Okay. So in the MapReduce program, like in the driver class, right, we have not used combiner. Last time I discussed what is combiner, right? You remember, you guys, like what is combiner? Okay. So combiner is like if the data is repeated in the same mapper, that will be making your performance degraded, right? What will happen? Suppose this hello, hello, hello is coming 100,000 times in the same mapper. So it will be giving each word is a one count. So how many times it will travel over the network? It will be transfer over the network hello comma 100,000 times. So I want in the same mapper, if the same word is there, why I should not aggregate itself is here? Because I cannot aggregate from the different mapper because that part is being done in the reduce. Okay, that part I don't need to handle, but mapper side, each individual mapper can do aggregate the same word. So that will improve the performance. If this hello is coming 2 times, hello comma 1, hello comma 1, why I can't make it hello comma 2? So that part is being done by this combiner. So combiner is a utility in MapReduce, which is aggregating the same key in the mapper itself. And we don't need to write any class for that. Whatever your reducer class, that is the same class. Can you see that this is the same class name? Word count reducer, right? So just I need to enable it. I have to just put this line job.set combiner class and reducer class name. So my combiner will come in picture. Okay. Okay, so this is the use of combiner, which is improving the performance of your MapReduce application. Generally, this combiner is very useful when the repeated data is more and you are doing word count and your repeated data is more. So that combiner is very useful. Okay. And otherwise you will not find any good performance if repeated data is not there, because combiner will be taking a same effort. Okay. And another one is partitioner. So I say if you are generating all the complete word count, all the word in a single file, if a few words are there, that is fine. But if I say millions of words are there or like 100,000 of words there, I'm saying to find one particular word count, will you search an entire file? You will search this entire file of the word count. You will search, right? This one. You will search the entire file, like this file. So here is the 4 or 5 words. That is fine. I can easily find. But suppose millions of words are there, 1,000 words, 10,000, 100,000. So you cannot find easily your one single word with how many number of count. So that reason we can use partitioner to distribute your data into number of output file. So suppose I say example, if my total, how many alphabets are there? 26. I can create a 26 files for each word, one file I can create. Okay. So whenever I want to know L letter word, I will go to the L letter word, then I can get my word. If I want to get A letter word or B letter word, I will go to A or B because I know A or B letter word will be in A or B letter word file. Okay. So I don't need to search each and every file. Okay. That's the one thing. So and suppose this is the one logic you are writing in the partitioner, but suppose you say you want to write some logic some output data you want to generate based on the male or female. Okay, so you can select the criteria. So partitioner is a custom partitioner class. You have to decide your logic. Suppose here I'm saying the logic is my start with H letter. So whatever file is coming with the H letter word, it will go to the H letter file, and A and remaining will go to the any character. It will go to the any file. It doesn't matter whatever it is. Okay, because I'm not creating a 26 files, right, for the demo. Okay, so it's no use. Just I'm going to say, right, it is possible. Suppose if I say male and female, I want to see. So my key is suppose I say I want to check whether it start with the male, or I can say equals, because start with I'm using it's a string function. I want to check whatever my starting letter, and then I'm going to distribute my data. But if I'm saying I want to check male and female, I can use equals method here. You know, in Java and Python, everywhere equals function is there. That is check equal the value of in your bracket. Okay. So here is a very simple logic. If my number of reduced task is coming 0, number of reduced task means how many output file you want to create. So suppose I say my number of reduced task 0 means I don't want to create, I want to keep it one single file. So 0 is for one file. Okay. If I'm saying if my num-reduce task is coming from my driver, if you see in my driver, I'm sending this parameter 3. I want to, if I'm going to send 3, so I have to write a logic for 3. I have to write a logic for 3, and I have decided here 0 is my 1 file, return 1 is a 1 file, and return 2 is a third file. Okay. So what happened? This partitioner will be at the mapper side. It will decide whenever it is sending the data to shuffle and sort, it will distribute, right? It will be distributing the data into the 3 different output file rather than going to the one single file. Okay. So what I need to do in my driver, I simply just enable these two property. I have to tell what is my partitioner class name and what is my num reduce task. Okay. If I don't give this parameter, what will happen? It will, when it will call the partitioner class and it will find in this partitioner class if the num reduce task is 0. So it will create only one file. So my code is very flexible, right? It will, if you are giving a num reduce task 3, it will work for that. If it is not giving, then it will work for single file. Okay. So the code process is same. Okay. Now I'm going to run code, and let's see for the same input file, how many files is going to create. Okay. I'm going to run my, this is going to create a jar, but I don't want to create jar. I want to run locally. So I will run my MapReduce WC. Okay. So this, if you see edit configuration, this is the Maven one. I have to go to application one. So I'm using the same, everything is same. My input folder is a test one, and my input file and my output directory, everything is same. Just I'm going to run this with partitioner because I have enabled my partitioner logic. Okay. And combiner, both are there. So it's not mandatory. Like even you want combiner, you can keep it. You want combiner only, you want to keep it partitioner only, you want to keep both, or you don't want anything, you can. But basic MapReduce program, you need.
ఎవరితో
Yeah. So, so what I'm saying here is like, okay, I have run the program now. Okay, let's go to see the output. Okay, so here I'm already in the test1 directory. Okay, I go to the output folder. Can you see how many files are created? 3, right? Part 1, part 2, part 3. Okay, so let's see content of part 1. Can you see how many words came in this? And only H word will come, letter word. Second one we see A letter. So what was my logic? My partition logic was saying my letter will start with H, that is the one file. Second file is, so 0, 1 means 0 file will go, 1 means 1 file, and 2 means second file. Okay. So if I check my 2, U, other. Okay. So all other will go to this third file. Okay. And here is combiner is also, but combiner effect you will not see because these are very less word. If you repeat the data, you keep it more in the file, you will see, right? Suppose here, okay, this is my file. I copy this line. Copy this. Okay, I copy this. You're able to see line is increasing. Okay. So now I save this file. Okay. So now I run this program. Okay, done. So it is almost taking a same time like last time you run for the 6 word, just little bit more, right? And this time how many words? Let's see. Okay, we do cd dot dot, again we have to come in output directly. Okay. See 11:32 is it, time is changed. Okay, part 00. So see first file, how many times this hello and hello is there? Hello. Okay, so this is correct number or not? How can we say this is correct or not? Okay, so we do one thing, we add one more word in this file, just only one word, so that we check whether it's correct or not. See, file is getting hanged. Okay, it's not able to, because this notepad or this cannot handle the large data, right? That's the problem. Or we can append here directly. We can. This is my file, test.txt. So how to append a word in the echo? Actually, I didn't do echo. Just I do hello. I want to append. If I use greater than sign, what will happen? Only one greater than sign. What will happen in this case?
It will redirect the output.
It will remove all the my previous content and it will keep it only one single word hello, right? Okay. It will overwrite my entire content. Okay. Okay. So actually maybe space came or not. We are not sure because, okay, let's see another word also. Okay. Now I run the code. Okay, done. Something is increment. 37 53 to 202. Okay. So hello, actually it become a one word. Okay. And it is coming in this category. So that is the reason this word is increment by this 135320. Okay, so this is the program for how to do word count for MapReduce partitioner, right? How to use partitioner. Okay. Okay, so two more programs are there. I want to show, then we will wind up session. Okay, tomorrow we'll do the hive. Okay, so that is the last one in the MapReduce. So in MapReduce also have the join, because we know about join like inner join, left outer, right outer. But here is the MapReduce, we do the join between the files, not in the like a table, because MapReduce we talk about the files, right? We are talking about the input file. So suppose my one file has some data and my output file has some data. So I can do the join between the two files. So there are two types of join. One is map side join and one is a reduce side join. So map side join is the join which is happening at the mapper side. Okay. So if you understand the map side join and reduce side join concept, so very simple way, Suppose I say I have a emp.txt file, okay, one text file, and I have emp ID, emp name, and I say department ID, dpt ID, and another file I have a dpt.txt. You know, inner join like the one primary foreign key we talk about. The same thing is here, right? But here actual primary key foreign key concept is not there because this is a text file, okay? And department ID and department name. If I ask you, I want to do the join between these two files and I want to result like this: employee ID, employee name, and department ID also I want to print, and department name, to make sure my department ID and department name both are correct. So if I want the output like this, I want the output into new output file with this header, So here you are not doing any manipulation. Generally, reducer you've seen when it comes in picture, when you are doing some calculation, right? Aggregation things you did, okay? But here you are simply doing like you are reading this file, and just making it like combining the column. You are not aggregating some result. So in this case, the join is called map side join. So map side join is you will read one input file. One input file is which is the larger file. emp.txt is a very large file because you will read. Generally, some companies have like thousands employee, 10,000, 100,000, like that number of quantity employee. But if I say department is a very small, right? Department hardly will be 10, 15 or makes 100 department max, I can say. But that will not be more than size is 100 KB or like some KBs of size, or maybe less than KB, right? So one file is very large and one is a small. So here in MapReduce, there is a distributed cache is there. So distributed cache like is a concept like you can keep it your small file in some directory and you read through cache. A small file read through cache directory. Okay. And you don't need to load data manually like one input file. So unnecessary, you don't need to load two mapper file. One mapper file you load and the other file you will take it from the cache. Okay. So that concept is, so what you need to do, you just need to search the data. Suppose your department ID, you will search here in this department table, department file, and get the department name and append it. That's the logic. So here you will have a Java is having the hash map concept, you know, key value pair. So that key value pair, the key value pair. So here you make it, your key is department ID and value is a department name. Okay. So you will create a data of key value pair of this department txt file. Okay. And the separation character, you can keep it. Okay. Comma is there or tab is there. It doesn't matter. So you will get a key value pair. So whenever you want to look up, right, you will say department ID, you will look up in this hash map and get the value of department name and then append into the this emp data. So how we will do in the, so here is no reducer code is required. So there is no reducer code. So if you see, there is a one driver class is there and one mapper class is there. There is no reducer class. So this map side join in the driver class, you are doing one thing is you are adding a cache file. And this adding cache file, you are using a Hadoop directory. You have to create this directory and you have this department txt file on Hadoop file system as a cache file. So you are providing a location. This is your root directory and there is a DC and there is a department txt. And other things are fine. And you are saying num reduce task 0 because you are not having any reducer. So you are setting your num reduce task 0. So there will be no reducer and you are not setting the reduce class also in the job, right? Okay. So this is the driver class. And when you come to the mapper class, so mapper class has one set of function is there. There you are reading your cache file. So how you are reading a cache file? First, you are checking how many cache file is there. So you have a one directory name cache file directory and you are checking in that cache file directory location if your file name is a department txt, because there could be a many other cache file. But you have to select your department txt cache file and get this file and call the function load hash map. So this function is reading your Java, right? A Java code, right? Read line by line code, and then you are separating your comma separated data, the department ID and department name, and putting in the hash map as a key and value. And then there is a map function. This map function is basically what is doing. First of all, you are having your, you are separating your entire data of line, okay? Like EMP ID, comma EMP name, comma department ID. So you got an array. Again, the same thing you are doing. And now you are finding the your last here is actually 6 columns are there in this particular data set. The 6th one is the department ID in the EMP data set. And this department ID you are passing and getting a is STR department name. And this STR department name you are setting into the your text of line. Okay. And finally, you are writing this text of line, you are writing with the key, and finally your data is written to your output file. So this time your output data will be coming as a mapper output file. So far you've seen part R, this time you will see part M because your output is generating from the mapper. Okay. So this is the concept of join. It's a very simple like a lookup process because map side join is a lookup process because you have some hash map, and the hash map you are searching your department ID key and value you are getting. Okay. So for this, like we need a 2 data set. Like one is we need a department txt file and we need one employee txt file. Okay. I have the data or not. Okay, meanwhile, I find the data. We take a 5-minute break. Okay, I just download the data. Okay, in my Google Drive. Okay, then I will show you the practical. Okay. Yeah, guys, are you able to see the screen? Okay, so I have copied the data. You are getting the voice? Hello?
Yes, Arvind.
Yes, Arvind. Yes, Arvind.
Okay,
Getting.
okay, fine. So what I did, I copied the data in Hadoop file system. Okay, so I copied the data here. Actually, I need a DC directory. So the thing is, first thing is in the map side join, I need my distributed cache and distributed cache directory. So first I need to create if I go to the driver, so here is this is the Hadoop file system directory, right? So I have to create this directory and copy this department.txt there, okay, as a distributed cache file. So I'm going to create in my Hadoop file system. So cd dot here my all the input files, everything is there. So in the DC, if I go, so you can see department.txt is there. Okay, so fs minus. So I am creating a separate map site join DC. The map site join DC. So this directory I'm creating. Why? What is the problem here? Why it is not allowing to create me directory? Yeah, guys, can you tell me? Why it is not allowing me to create a directory? Right, I'm trying to create a directory, right? So this is the command only, right? Right?
No, you can't do that.
Hmm?
You can't do that because you have to use a minus p. to do it.
Yes. Because I'm trying to create a two directory without giving minus p, right? So it will not allow. Nested directory you cannot do. Okay, but minus p it will allow. Okay. Okay, so that was the correct reason. Okay. So now I'm going to put my file. So cd dc I will go and Hadoop fs minus put, and my file is the department.txt. This file I want to copy map site join /dc. Okay. So first thing I have done, my one distributed cache, right? My cache file I copied. So my this part is done. Okay. So next is I need a one more input file, right? So my one input file is an emp.tsv file. Okay. So if I check here, there is a one employee tsv. So if I show you the data, if you see, this is the data, and here is the one department ID coming at the end, right? And if you want to see the cd.dc and check cat department. So this one has your department. So can you see the department IDs are matching? This D001, D004, 5, 6, 7, 8, 9, right? So some departments are matching, right? Some employees are not there. It is not mandatory, right? Because department can be 100. So it's not necessary. Whatever employees you are showing, all should have the they should be on all department. Okay. So some of the department there's a data is not there. That is fine. Okay. Now I need to copy this employee TSB file in my Hadoop directory. Okay, so Hadoop fs minus put, because input file is needed now, mapper file. So now I'm copying to map site join. I'm not copying in the DC, I'm just copying outside, just map site join. Okay. Okay. And now what I need to create a jar. Okay, I have not done any change. So I can use the same jar. So I have a jar already there. I have not done any change in the code, right? So my same jar, fine. But my driver class will change now. So now I will use Hadoop jar. Okay, how to see the, what is the complete command? Hadoop jar name, Hadoop jar, MapReduce jar name. Okay, what is my main class? Now my main class is different main class. My main class is this driver map and with package. So org.example. My main class and input file. My input file is the TSV file, right? The employee TSV. So complete path I have to give map site join / employee underscore TSV as it is named, because there is no extension. This is not extension. Underscore TSV is a name. Okay. Extension means in the Linux is the case sensitive, is the file name. Okay. Because if you are giving .txt or something, then you have to use that. Otherwise, it will not give you the correct file. And now next is a output path. So output path you will create map site join / some output directory. Okay, this is my command format. Okay, now I'm running my job. So another ID is created or not? Last time you seen 001 was there. So now I will refresh my page. You remember, right? This one. So if I go back here and I will see one more job is started. Okay, so if you refresh this cluster, can you see 002? And it is just finished now. The 002, this job is finished now. Okay, now I check in my. So can you see here it is completed? And how many input record it read? 7. How many output record came? 7. Both are same. Okay. Now I want to check my output data. ls map site join / output. So here is my output file. So what extension should come the file? Map site join. Part M. I told you, right? It will not be part R because we are not using reducer. Can you see part M is there? Hadoop fs minus cat. I will give a complete path. Yeah. So you should get the department name also this time. Can you see the department name? D005 is a development department. D005 is a development department. D005 is a development. It's correct. How many D004? 1, 2. D005 is your D004 is a production department. D005 is a development, and D007 is a sales. So D004 like 2 development, right? 2 production, sales is 1, human resource is 1, and quality management is a D006. So it means our mapping is correct, right? So our data is properly mapped. Okay. So this is a map site join. And one more last join we are going to see, that is a reduce site join. Okay. So reduce site join. Reduce site join, first we understand what is the concept of reduce site join. So map site join you understood, only one mapper and one file is in the distributed cache. But the reduce site join is basically the join between the two large files. Okay, so that is the difference between the map site join and reduce site join. So reduce site join is the file is two large file. So suppose I say one customer file and one order file is there, or transactions file. Okay. So if I say customer record and transaction record, there will be, which file will be large? Customer data will be large or transaction data will be large? What do you say? Customer data will be large file or transaction data will be large file? See, if I'm saying all customer has one order, okay, at least one order, so definitely it will be equal. But if I'm saying one customer can purchase every month 3 times, 2 times, or 10 times, so how many transaction record for the same customer? It will be multiple record, right? So here is the size is near equal, I'm saying, right? Both the size is the file is the size, large size file. So in this case, we will do 2 mappers. One called customer mapper, because we are reading both the file as a mapper file, and one file is a transaction mapper. Okay. And what I need to do, I will be doing these 2 files, and I want to find a one common ID, so I can identify, okay, this customer has this transaction, this customer has this transaction. So in the reducer side, I will aggregate reducer side. Okay, I will aggregate the total cost of the order for a customer and total number of transaction for the customer. Okay, so that aggregation I will do. But the question comes, how can you recognize? Because mapper will be sending customer data, this transaction mapper will be sending transaction mapper. But reducer is only one. How it will identify, okay, this is customer, this is transaction data. So there is a prefix we need to add. So here in the customer mapper, it will add cust underscore prefix and cust ID. Okay, here is like transaction prefix and tran ID. Okay, so like this, if we add it, so now reducer will be easily identify, okay, this is the customer, so customer name it has to take. If it is a transaction, it has to take the amount, because transaction data has the amount field. Okay, so this kind of join, so we have written one single class written, and this is an example of how can you write a multiple classes in a one single file. So customer mapper is a one class. What I'm going to do, I'm reading my line of text. Okay, first we see the data, how data is there. Okay, so ls cat cust detail. I'm showing you cust details. Okay, cat transaction detail. So can you see here this 4001 one customer ID, which is a foreign key in the transaction detail. So how many transaction for this customer ID 4001? How many transactions? How many transactions? One or two?
Two.
Two. And for customer ID 4002, how many transactions?
One.
And 4003?
One.
And 4004?
004.
0. So there is no transaction. So if I say number of count will come like this, okay, 1 will come 2, 2 will come 1, and 3 will come 1, and 4 will come no transaction. Okay. So, so here is the common key I identify. This is the customer ID. So what I'm doing in my code, so whenever I'm reading the data, the first part, right, when I'm just array, I'm converting array by comma separated data, I separate it, and first value is my customer ID I'm adding, and I'm adding as a cust is a prefix, and I'm adding the part 1, that is my, what is my part 1? So part 0 and part 1. So part 0 is this, and part 1 is a name. Because why I'm adding the name as a value? Because I will need to print the customer name. Okay. And the transaction data, the part 2 again is a customer ID. These two are same or not? Here it is a customer data set, and this is a transaction data set. But this is same, right? This is 0 is here customer ID, and here is a 2 means 0, 1, 2. That is again same customer ID. Okay, so I'm taking a common key. When it will go to the reducer, I will identify for the same customer the transaction, right? And transaction record I'm adding, the value part I'm adding, transaction, the prefix, so that I can identify. And part 3, if you see in the transaction data set, part 3, 0, 1, 2, that is my customer ID. Okay, so part 3, no, cost, sorry, 0, 1, 2, 3, 45.67. Okay, 78.60. So I'm keeping it two details. One is a customer name, and one I'm keeping it the transaction amount. And now when I come to the reducer, so there is a single reducer class. And what this reducer class is doing, it is iterating the data. It is iterating all the data, whether it's a customer and transaction. First, I will identify if condition, whether it is matching my part 0 is a transaction or cust. If it is a transaction, I need a count plus of the transaction, and total amount will be total my 0, 0.0, and I'm adding it, adding for the same customer, how many transactions are there, all the amount will be added. Else if it is not a transaction type mapper data, it will take a customer and then take part 1 is a name of the customer. And finally, I'm preparing one string, just combination of these two things. What are the number of total transaction count, and total amount is the total value. Okay. And finally, this str I'm writing as a new text str, and the key will be what is this key? Name. So name is a key and value is the this entire formatted text. Okay. And when I'm invoking the driver and everything I'm giving, but here one more thing I'm using two mappers I'm giving using the multi-input format. Here it is not an input format type. It is not a single file. It is a multiple mapper. Okay. And output path is the same. Okay. So now if I want to run this program, I will create an application here that already I talked about. So edit configuration. So I have already reduced site join. So now I have to change I have to just verify this path is correct or not, all three parameters. So this is my home. This directory is this particular customer detail file where it is. So this particular customer detail file, if I do pwd, so this is in my test1 directory. Okay, so I've changed it. Test1. Okay. Second input file. Again, this is a test1 because in the same folder, both the files are there, right? And this is my transaction detail file. And finally, my output directory file. So output directory also, I say this is my test1. Test1. And output directory name, I kept it anything. Okay. It's already not there. So not a problem. Okay. Okay. And now I run this reduce site join. So this is a reduce site join. Okay, just verify again the configuration, edit configuration. So whatever changes I did, oh, I didn't save. Test1. Test1. So I run it now. Okay, so now I should check. So where I should get the output directory. Output 1. Okay, the name of the directory came output 1. Okay, so output 1 is my output directory. Okay, output 1 is my output directory. So cd output 1. So part R file you are able to see. And when it is created, 1208, just 1 minute ago. Okay, so I'm checking the output data. Can you see the customer name? Test2, test. Okay, test is a customer name. Test is a customer name. Test is a customer name is a 4001, and he has 2 transactions. It's correct. And 124 is the total amount. So if we calculate here 4001, 4578, it's approx 120, 124. And test 2 has 1 transaction, test 4 is a 1, and test 6 is a 0 transaction, 0 amount. Test 4 is having 1 transaction, 98. Can we check 98 is there? 98.90. Okay, and 89.90. Okay, so you can see the result as an output. So this is result is coming after your reduced site join. The same thing you can do in Hadoop file system. What you need to do, you have to copy this all input file output in this 2 mapper file in the Hadoop file system, and then you can run the same job. Okay, because this all main classes, like whatever you practice, right? Map site join, reduce site join, or partitioner, combiner, everything is in the same jar. So which main class you have to use? Give that jar, that class name in your, and jar name is the same. Okay, so you can do practice with all these examples, and practice for in how to run in Hadoop file system. I'm not saying for all the type of example you run, but at least 1 or 2 examples you run in Hadoop file system, and 1 or 2 examples you run in IntelliJ. Okay. Okay, so next I will be taking a Hive session and Scoop. Tomorrow I'll take, okay, Hive and Scoop. So Hive is completely data warehouse tool and Scoop is the ingestion tool. Okay. Okay, I will upload the recording in the LMS, like in the classroom, okay, Google Classroom. So you can see the recording and you can do practice. Okay. Okay, anyone has any question? Okay. And the previous session, you go through the video. Okay. So I will cover up, right? Anyone wants like, na, I will take one backup session starting from our main session. Okay. 30 minutes. Okay. So I already discussed the previous things, right? Like some, but it's still some Hadoop file system, right? One Java API and the curl. So this is pending. Okay. So that we have to do. Okay. And apart from this, like you just check it out, what you have completed that make, I have provided Excel sheet. So mark it in your Excel sheet, right? What you are completing, what practical you have done, put it in comment. I have given the link, right? Everyone has. So just do that. I will upload in the classroom that Excel. So you can checklist mark it, right? Whatever your preparation you are doing, whatever the mock interview questions you are preparing any document for that. So just make it your own copy and update it. Okay. And if you prepare any mock question related document and you want to share to everyone, so you can share, right? Okay. Yeah. Hadoop configuration session. What is this? I missed the configuration session. Hadoop MapReduce file. So MapReduce, I explained today, right? The word count, and previous session also MapReduce word count is there. Okay. Yeah, go through once. Let me know. I will explain you separately. Okay. If you have more questions. Okay. Thanks, everyone. Thank you.